Hey, what's up guys? We're going to look at measuring the specific heat capacity of a material. So let's recap. What is the specific heat capacity of material? It's the energy required to heat up 1 kilogram of a substance by 1 degree Celsius. And we have this equation. The energy is equal to the mass multiplied by the specific heat capacity multiplied by our change in temperature. And that's the equation for how much energy is required to heat a substance up. Let's have a look at water, for example. The specific heat capacity of water is about 4,200 joules per kilogram per degree Celsius. This means that it takes 4,200 joules to heat up 1 kilogram of water by 1 degree Celsius. But how do scientists know the specific heat capacity of water and any other substance? Well, they have to do experiments, and this is an experiment that you need to know for your exams. So let's have a look at the equipment we're going to use, and then we'll look at the method afterwards. First of all, we need a mass balance, and that's to measure the mass of our block. And we measure the mass in kilograms. We need a thermometer to measure a temperature change, and we always measure temperature in degrees Celsius. The immersion heater is going to provide the heat to our metal block. It's going to heat our metal block up. And where it gets its energy to do that is from the power supply. So the power supply supplies the energy. And we're going to use a 12-volt DC supply. The potential difference that we're using isn't really important. I'm just using 12 volts because it's a sensible voltage to use. The joule meter is a piece of equipment you've probably not used before. And this measures how much energy. So we need to know how much energy is going into our heater and into our metal block. Therefore, we need to use a joule meter to measure that. And insulation, this is really important. The insulation goes around the metal block that we're going to heat up and it reduces heat loss. We want to make sure that all the thermal energy goes into the metal block and isn't dissipated into the surroundings. So that's our equipment. Let's have a look at the method that we're going to use and the calculation that we have to do to determine the specific heat capacity of our metal block. So the equation for the energy required to heat a substance up is given by energy is mass multiplied by specific heat capacity multiplied by the change in temperature. But for this experiment, we want to know the specific heat capacity. So let's rearrange this equation. C is equal to the energy divided by brackets, the mass multiplied by the change in temperature. So if we want to know the specific heat capacity C, we just need 3 measurements. Number 1, the energy supplied to our metal block. Number 2, how much mass the metal block has. And number 3, the change in temperature as a result of heat in that metal block. So let's go through and describe how we perform this experiment. Step 1, we're going to use our mass balance. And before we begin anything, we're going to put our metal block on this mass balance and we're going to measure the mass on the mass balance. We're going to do that in kilograms. Very simple. Step 2, this is where we're going to connect our circuit. So we're going to take our power supply, we're going to connect it using leads to a joule meter and connect the joule meter to our immersion heater. This is so that the power supply can supply electrical energy to the immersion heater, which converts the electrical energy into thermal energy, which we're going to use to heat up our metal block. The joule meter's job is to record the amount of energy we're supplying. Step 3, we're going to place our immersion heater inside the metal block. This is so that all of the thermal energy from that immersion heater goes into the metal block and then it heats the metal block up using conduction. Step 4, we place our thermometer inside the metal block because we want to record the temperature of that metal block. So you place it within the metal block and you record the initial temperature before you begin to turn your heater on, before you begin any heating. You need to know what is the temperature that it started at. The next step is that you turn your power supply on. So this provides electrical energy and it passes through the joule meter and it goes into the immersion heater, which converts the electrical energy into thermal energy. And then that heats up the metal block. I'm going to say turn the power supply and the heater on for about 10 minutes, but it can take longer. You just need to leave it for as long as it takes to get a sensible, reasonable temperature change that you're able to measure easily. The next step is to turn your power supply off. Then you record the energy supplied on the joule meter and you record the final temperature using the thermometer. Next step, you need to calculate the change in temperature. And this is simply the final temp, take away the initial temp. And that gives us our change in temperature. And we're almost there. The last step is to simply calculate the specific heat capacity. And this is where we have to go back to our equation here. And we know that the specific heat capacity is the energy divided by the mass multiplied by the change of temperature. And those two are in brackets. It's really important to remember the brackets there. And when you substitute in your values for the energy, the mass, and the change in temperature, you'll have your value for the specific heat capacity of your material. So let's just quickly run back over that. If you want to measure the specific heat capacity of a material, you need to know the energy, the mass, and the change in temperature. So you measure the mass on the mass balance. Then you're going to connect your circuit as you've got here, where you have a power supply connected to a joule meter and immersion heater. You then place the immersion heater inside the metal block. You then record the initial temperature, the starting temperature, using the thermometer before you turn your heater on. Then you turn your power supply and your heater on for 10, 20, maybe even 30 minutes so you get a good temperature change. You then turn it off and you record how much energy has been supplied on a joule meter, and you record the final temperature using your thermometer. Then you calculate your change in temperature, and then you simply substitute everything into this equation at the bottom, where the specific heat capacity is the energy divided by the mass multiplied by the change in temperature. It's as simple as that. There's a lot of steps for you to go over there, but it is really important. And you just have to think logically and always go back to the equation. You need to know the energy, the mass, and the change in temperature. And that's it. Thanks for listening. See you all soon.